This video is going to talk about the metric system and common units used in chemistry. First off, we're going to go over the metric system really quick. It's a standard system used in science, and it's based on the powers of 10. There are SI units. SI is international system. Those are 7 units that are used in science, and all other units are based off of them or derived off of them. Not all those units are used in science. In chemistry. The ones we use the most are mole and K for Kelvin. Kilogram, we tend to use gram or microgram or milligram. Prefixes, I want you to know. I'm going to skip the ones I don't want you to know. Kilo, so you need to remember that 1 kilometer or 1 kilogram or 1 kiloliter would be 1,000 meters. Centi, 1 meter or 1 gram or 1 liter would be 100 centimeters. Sorry. Milli, 1 meter would be 1,000 millimeters. Micro, 1 meter would be 1 million, or I'm going to write it 1 times 10 to the 6 micrometers. Milli could have been written 1 times 10 to the 3rd. Nano, 1 meter is 1 times 10 to the 9th nanometers, and pico, 1 meter would be 1 times 10 to the 12th picometers. Common measurements for length, we use a meter, and a meter is approximately equal to 1 yard. Another way to eyeball it, the height of a doorknob is almost 1 meter. And 2.54 centimeter is 1 inch exactly. That means the inch 1 has unlimited number of sig figs, same as the 2.54. It has an unlimited number of sig figs because it's defined exactly. For volume, milliliter is the most common unit of measure. A milliliter is equal to 1 cubic centimeter. One cubic meter would be 1,000 milliliters. A liter is a cube that would be 10 centimeters on each side. So that means a liter is equal to 1,000 cubic centimeters, or 1,000 milliliters, since 1 milliliter is a centimeter cubed. Forgot the cube there. Different equipment used for measuring volume. You should know by now a graduated cylinder, which you have in your drawer and you used the other day. The 25 milliliter graduated cylinder. Pipettes are used. Burettes are used. I'll show some of these tomorrow in class. Mass is the amount of matter something contains. So we mass things in class. Weight is a force, and it depends on the location. Your weight's different on Earth versus the moon. 1 liter of water at 4 degrees Celsius has a mass of 1 kilogram. The kilogram is the standard, and the IPK I talked about in class the other day is somewhere over in Europe. That's actually defines what the kilogram is. It's losing mass, so the kilogram's slowly getting smaller. Temperature is how hot or cold something is. Heat always travels from hot temperatures to cool temperatures. And heat causes most matter to expand. The exception would be water. We will use both Kelvin and Celsius. Kelvin relates to Celsius. All you have to do is add 273. One thing I want you to note is Kelvin does not have a degree symbol. Celsius does. Absolute zero is the temperature at which all motion stops. And it's the lowest possible temperature. It's never 0 Kelvin has never been achieved, but they've got close to like 0.00001 Kelvin in a lab. And then energy is the last unit that we'll see throughout the year, and we'll use both joules and kcals for the most part. A food calorie is not a calorie, so there's a food calorie with a capital C, and there's a calorie in science with a small c. They're not the same thing. A food calorie is equal to 1,000 small c calories. So when you're looking on your Snickers bar and it says it's 240 calories, it's also 240 kilocalories. That's it. See you in class.